It began as a whisper against the infinite, an echo in the quiet data streams of deep space, a faint reflection slipping through the digital night. Long before the world would know its name, before headlines screamed and telescopes turned, there was only a flicker, an anomaly so small it might have been noise. Yet within that whisper lay the seed of panic, wonder, and revelation that would grip the scientific world in 2025. They would call it 3I ATLAS, the third interstellar object ever recorded. But in the beginning, it was simply a stranger from the void. Space is not silent. It hums with radiation, with photons billions of years old, with the breathing of stars and the sighs of dying galaxies. Somewhere within that endless song, an object had crossed the thin, invisible membrane that separates one star system from another. It drifted from darkness into the faint, golden light of our sun, an intruder, untethered, untamed. Its path was not random. It traced a line of intent, as if following a forgotten map. The cosmos had sensed something again, and this time it seemed to be looking back. Astronomers had waited for such a moment since 2017, when Oumuamua passed through our solar family like a blade of light, an enigma that defied gravity, reflection, and reason. It was supposed to be an accident of nature, a fragment of ice or rock ejected from some ancient collision light years away. Then came 2I Borisov, a comet by all definitions, more ordinary, more predictable, and thus reassuring. But 3I ATLAS was neither familiar nor forgiving. Its motion was sharp, its albedo strange, its behavior unnatural. NASA's early detection network flagged the signal in near real time. The ATLAS Survey Asteroid Terrestrial Impact Last Alert System was built to guard humanity against extinction. Ironically, it would now be the first to herald what many would call NASA's worst nightmare. When its computers mapped the object's trajectory, a thin red arc sliced across the Earth's orbit. A probability small but not negligible appeared on the screens of planetary defense officers. The universe, it seemed, was sending a test. News of the discovery spread through internal channels before the public announcement. There was excitement, but beneath it, a tone of unease. The numbers whispered something that instruments could not explain. The velocity unbounded by solar gravity confirmed an origin beyond our star. The object was fast, too fast, and yet it decelerated slightly as it approached the heliopause, as though sensing the gravity of its new host. The data felt alive. Scientists are trained to dismiss emotion from observation, but there are moments when even equations seem to shudder. The first composite images from ATLAS showed an elongated shadow, reflective yet muted, like obsidian soaked in silver. It shimmered in ways that ordinary bodies did not. Its light curve pulsed, not with rotation, but with rhythm, a pattern, a beat. The initial assumption was that it tumbled irregularly, producing apparent pulses of brightness, but subsequent analysis showed timing that was too precise, almost metronomic. ATLAS technicians, hesitant to use the word signal, instead called it a consistent modulation. For the first time since the dawn of the space age, the data seemed to speak back. In the following days, observatories from Chile to Japan turned their instruments toward the coordinates. The James Webb Space Telescope caught faint thermal emissions, unexpected for an inert rock. Something on or within the object was generating heat, not reflecting it. Solar photons alone could not explain the spectrum. By the time NASA's Jet Propulsion Laboratory had processed the light curve data, the story had already escaped containment. A leak, perhaps intentional, perhaps accidental, carried the term 3I ATLAS onto message boards and forums. Within hours, social media was ablaze with speculation. Alien probe, stealth comet, dimensional artifact. The truth was far stranger. It was that no one, Not even the brightest minds at Caltech or CERN could tell what they were looking at. In documentaries yet to be made, historians will replay those first 72 hours again and again, the slow realization, the cautious excitement, the shift from curiosity to dread. But at that moment, in early 2025, the story was still pure possibility. Michio Kaku, speaking on a late-night broadcast, described it as the most profound encounter since the dawn of observation. His voice was calm, yet beneath it was awe. "If this object is what the data suggests," he said, "we may be witnessing not just a visitor, but a messenger from the architecture of the universe itself." In the deserts of Arizona, telescopes watched it grow brighter by imperceptible degrees. Each night it drew closer, slicing through the Kuiper Belt, its path unwavering. Beyond the static and noise, beyond the mathematical fits and orbital solutions, one truth began to crystallize. This was not another frozen relic drifting between the stars. This was something different, something deliberate. And as it crossed Neptune's orbit, still decelerating in defiance of gravity, the world's finest instruments turned toward the void, searching for the reason the universe had sent it here again. The moment of discovery was not marked by celebration, but by confusion. At 3:12 a.m. Hawaiian Standard Time, the ATLAS telescope on Mauna Loa registered a dim trace, a light no brighter than a smudge on a digital sensor. Automated filters dismissed it as cosmic noise, a glitch in the stream. But the system, trained by years of vigilance, reflagged the event 6 minutes later. The same trace reappeared in a slightly altered position. A second instrument, 30 kilometers away at Haleakala, confirmed it. 2 points aligned across distance and time. Something real had moved between them. Dr. Lena Morimoto, a quiet, precise astronomer who had spent the last decades scanning for planetary killers, leaned toward the monitor. "Velocity?" she asked. The technician hesitated. The figure on the screen was absurd, 56 kilometers per second relative to the Sunday. Not unheard of, but far higher than expected for anything gravitationally bound to our system. The object, still unclassified, was inbound on a steep hyperbolic curve. Within minutes, the event log was sent to NASA's Center for Near-Earth Object Studies. They cross-checked with Pan-STARRS, with Gaia, with radar sweeps from Goldstone. Each confirmed the same anomaly. It was moving too straight, too fast, as if gravity were a suggestion rather than a law. For 2 hours, the discovery remained a secret between a handful of sleepless scientists. They whispered through secure lines, trading possibilities that sounded more like science fiction than data analysis. "Ejector from another star," one said. "A rogue fragment," said another. Or something driven. No one dared say the word artificial, but the implication lingered, unspoken yet heavy. By dawn, the catalogue entry appeared, 3I Atlas. The third confirmed interstellar object, the I for interstellar, the numeral marking a growing, uneasy lineage. Oumuamua, the messenger. Borisov, the wanderer. And now, Atlas, the bearer of burdens. The name was fitting, the telescope that found it, and the mythic titan who held the heavens. News spread quietly at first. Within NASA's corridors, among the European Space Agency's servers, through the hum of data links to Tokyo and Geneva, scientists across time zones pulled up the same images, a thread of light shifting against the static tapestry of stars. In those first hours, the world of astrophysics was united in wonder. Discovery still had a heartbeat of innocence then, before fear seeped in. The Haleakala team tracked it again the next night. It had brightened by 2 magnitudes, far too fast for reflection alone. Some internal process, they guessed, was amplifying its light output. Perhaps outgassing? Yet the spectral bands showed no traces of water, carbon, or silicate dust. It was not venting like a comet, it was clean. Across the ocean in Pasadena, JPL's Orbital Dynamics Lab fed the numbers into their models. Each iteration came back stranger. "It's not closing its trajectory the way we expect," said one analyst. "Almost like it's correcting itself." That phrase, correcting itself, would haunt the following weeks. The discovery was announced to the public 48 hours later, a simple press release. ATLAS Observatory has identified a new interstellar object entering the solar system. Preliminary data suggests an extrasolar origin. Tracking and analysis ongoing. No panic, no warning, just sterile precision. Yet within minutes, social media seized it, inflating rumor into prophecy. Some recalled the panic of Oumuamua's arrival. Others remembered Stephen Hawking's warning that humanity should not respond to interstellar messengers. Meanwhile, inside the ATLAS control room, the team watched as their find began to evolve before their eyes. The object's light curve revealed a strange flicker, consistent intervals, almost rhythmic. At first they assumed tumbling rotation, but the timing was too precise. One interval lasted exactly 37.2 seconds, the next the same. Over hours, the beat remained constant. The cosmos, it seemed, had a metronome. Word reached theoretical physicists within days. Michio Kaku, in a live interview on NHK, described it as a whisper from the deep structure of the universe, a punctuation mark in the story of space and time. His poetic tone only deepened the intrigue. At the European Southern Observatory, Dr. Marcel Thorne compared 3I Atlas's early trajectory to that of 1I Oumuamua and found unsettling symmetry. Their approach vectors aligned within less than half a degree when traced backward into interstellar space. Coincidence or lineage? By the end of the week, the International Astronomical Union convened a closed session. The agenda: verify classification, discuss potential planetary risk, and determine how much of the raw data to release. Behind polite scientific language lurked anxiety. For every kilometer 3I Atlas traveled, certainty evaporated. At the time of discovery, it was still far beyond Saturn, an ember in the cosmic dark. Yet its apparent deceleration as it neared the heliocentric boundary defied every known mechanism. No dust jets, no radiation pressure anomalies, no magnetic drag. "Something's taking its foot off the gas," joked one analyst. No one laughed. For context, Oumuamua had also shown non-gravitational acceleration, but in the opposite direction, speeding up as it left the sun's influence. Now, its successor seemed to do the reverse, as if bracing for a rival. Telescopes, worldwide, synchronized tracking. The Vera Rubin Observatory, still in early operations, captured deep-field imagery showing a faint envelope of plasma trailing the object, an ionization halo, without known source. Radio dishes swept its path, listening. Silence. Or perhaps not silence, but something too structured to dismiss, too faint to decode. Discovery is often romanticized as triumph, yet in this case, it felt like intrusion. Something was entering our system without invitation, its purpose unreadable. Humanity had become the observed, not the observer. The date, the 19th of January 2025, will be remembered not as the night we found something, but as the night something found us. And as the data streamed down from Mauna Loa, Lina Morimoto whispered into the hum of machinery, "It's beautiful, and it's not supposed to be here." Her words would echo across countless screens, quoted, reprinted, and replayed. The phrase that defined a generation of scientists who suddenly realized the universe still held secrets large enough to make us feel small again. There are moments in scientific history when numbers stop behaving, when the language of the cosmos falters and something slips through the cracks of our understanding. That was what began to happen in the weeks following the identification of 3I ATLAS. It wasn't just that the object was fast, it was defiant. Its trajectory, when plotted on the precise maps of orbital mechanics, began to warp away from expectation, curling subtly against the gravitational gradient of the Sun, as though nudged by an invisible hand. The data from NASA's orbital models came in waves, each more unsettling than the last. Every hour of observation required a correction. Every prediction ran slightly behind the actual motion. The team at JPL referred to it privately as the drift, a term that seemed too simple for what they were seeing. The object's path wasn't chaotic, it was purposeful, as though responding to something unseen. In the long nights of calculation, computer monitors glowed like altars to reason. Equations cascaded down screens, adjusting for solar wind pressure, radiation recoil, even relativistic effects. Nothing held. The math refused to settle. At one point, a junior physicist recalculated the path using a full general relativity framework. The object still bent away from the curve. "It's steering," he said under his breath, half joking, half afraid. The phrase spread like static across NASA's internal chat rooms, half humor, half horror. It's steering. The physics of celestial motion are supposed to be simple, elegant, obedient. Everything that moves in the heavens does so for a reason: gravity, inertia, light pressure. But 3I ATLAS moved like something that knew it was being watched. The object was first observed at a velocity of roughly 56 kilometers per second, hyperbolic, interstellar, unbound. Yet by the time it reached the orbit of Neptune, its speed had dipped below projections by nearly 2%. That deceleration should have required tremendous energy, the kind no natural body could expend. And yet it continued to slow as it curved sunward. "What if it's not slowing down?" suggested a voice in one of the late-night teleconferences. "What if it's space itself distorting around it?" The idea hung in the air, absurd yet strangely plausible. If the object carried a gravitational or electromagnetic field of its own, even faintly, it could be warping the very geometry of its motion. Michio Kaku, interviewed on Science Nation, leaned forward as he spoke. "This is not merely an asteroid behaving oddly," he said softly. "It's a mirror reflecting our ignorance. Either this object is propelled by unknown technology, or we are witnessing a natural phenomenon that defies the current boundaries of physics." He reminded viewers that the term interstellar doesn't just mean from another star. It means from a place where our physical constants may not entirely apply. For the first time, serious scientific voices began to entertain the unthinkable that 3I ATLAS might be interacting with the vacuum itself. Perhaps magnetic resonance between its material and the Sun's heliospheric field created a kind of quantum buoyancy. Or perhaps it was not matter at all, but something embedded in space-time, a knot, a scar, a remnant from the early universe moving through us like a ghost through walls. The mathematics of its drift forced cosmologists to revisit equations long left to theory. Could an object possess negative mass density? Could it be exploiting the Casimir effect, drawing momentum from vacuum energy? The strange part was that the deflection wasn't large, it was subtle, graceful, like a feather caught in a faint breeze. But the pattern was consistent. Every anomaly whispered intent. Amid the calculations and sleepless nights, a quiet fear began to bloom. If 3I ATLAS could manipulate its motion through non-gravitational means, then it was no longer merely a visitor, it was navigating. NASA's Planetary Defense Coordination Office re-ran the orbital projection under dozens of models. One by one, the lines began to intersect thin threads of probability tracing paths perilously close to Earth's orbit. None guaranteed collision, but the possibilities multiplied like shadows in a narrowing room. They called it the gravity corridor, a region of space near 1 astronomical unit from the Sun, where even small perturbations could alter an object's fate dramatically. If 3I ATLAS were truly controlling its course deliberately or not, it could use that corridor as a slingshot or as a descent path. And yet, through all the tension and uncertainty, one emotion dominated the scientific community: wonder. Because in its defiance of gravitational law, the object was teaching physics to doubt itself. At Caltech, Professor Amara Vail described the trajectory as a choreography of silence. In her lecture, she compared the motion to a leaf gliding not on air, but on the curvature of time itself. Her students fell quiet, listening as she replayed the animated simulation, an elegant curve through the dark, smooth and unbroken. Across the world, public fascination ignited. Animated renderings flooded the internet. News outlets spoke of the cosmic visitor steering toward Earth. Hashtags turned into prayers and protests. Some feared impact, others dreamed of contact. In this new mythology of data, 3I ATLAS became whatever people needed it to be: prophecy, punishment, proof. Inside the laboratories, scientists avoided such words. They spoke of vectors, energy signatures, data points, but beneath their precision lived something ancient, the same trembling awe that Galileo must have felt when the heavens first moved under his gaze. Then, an unexpected update arrived from the European Space Agency's Gaia Observatory. The faint distortion in the star field near 3I ATLAS's path wasn't due to measurement error, it was gravitational lensing. The object was bending light, ever so slightly, more than its estimated mass should allow. It wasn't just drifting, it was pulling space around itself. Suddenly, all previous assumptions collapsed. If the readings were true, then 3I ATLAS possessed a localized gravitational anomaly, something far beyond any natural explanation. And as one astrophysicist whispered during a late-night call, staring at the glowing curve of the orbit on her screen, if it's steering, maybe it knows where it's going. By February 2025, 3I ATLAS had crossed the orbit of Uranus, and the silence of its passage had become deafening. NASA's data channels hummed day and night, but what those channels carried wasn't comfort, it was contradiction. The numbers refused to obey. Its mass, inferred from gravitational influence, was inconsistent with its luminosity. Its density changed with distance. It behaved as if parts of it existed and did not exist at the same time. Spectral readings from the James Webb Space Telescope came first. Analysts expected a dull, carbon-rich profile, maybe flecks of ice or metallic stone. Instead, they found a jagged, shifting spectrum, chromium, nickel, and an unknown series of absorption lines that didn't match any terrestrial element. The lines shimmered faintly between infrared and ultraviolet, defying categorization. "It's not alien metal," one chemist said. "It's just something we've never seen before." Radar mapping from Goldstone added another layer of impossibility. The signal bounced back with delays inconsistent with the object's measured distance. Some pulses returned too quickly, others too late, as if part of the surface absorbed radar and re-emitted it milliseconds later. When visualized, it produced a ghost image, one body and a faint echo of itself, separated by a few hundred meters, a twin shadow displaced in space or in time. They called it the density gradient. One side of 3I ATLAS appeared heavier, denser than the other. Its center of mass didn't align with its geometric center. In nature, such asymmetry should have torn it apart long ago, but 3I ATLAS remained whole, gliding through the void as if reinforced by some unseen architecture. NASA's Advanced Propulsion Laboratory at Glenn ran the data through their algorithms designed for spacecraft material analysis. The model returned a density estimate, 32 grams per cubic centimeter, more than twice that of osmium, the densest known metal, impossible for any natural asteroid, even one forged in the cores of dying stars. But the strangest part was that the density wasn't constant. It varied slightly over time, as if the object was breathing. In the dark hours of data review, engineers would stare at those oscillations, tiny rhythmic fluctuations that mirrored the earlier light curve. It was as though the object's structure, mass, brightness, even electromagnetic signature was pulsating in unison, like a single organism rather than inert rock. Theoretical physicists began to whisper of phase transitions, of matter caught between quantum states. Maybe 3I ATLAS wasn't a solid body at all, but a coherent field matter stabilized by electromagnetic confinement, a living plasma, frozen and folded into form. Michio Kaku, addressing a symposium at Columbia University, offered a different analogy. "Think of it," he said, "as the fossil of a technology too advanced for us to perceive. What we call matter might be merely the footprint it leaves behind." The auditorium fell silent, the air heavy with awe and disbelief. "If it truly can alter its own mass," he continued, "then we are looking at an object that bends not just space, but the rules of existence themselves." Meanwhile, inside the ATLAS team's data center, Dr. Lina Morimoto studied the object's spectral variations hour by hour. She noticed something no algorithm caught. The peaks of its irregular elements were in harmonic ratios, like overtones in a musical chord. 2, 3, 5, 8 Fibonacci intervals. It was almost too poetic to be coincidence. She hesitated to report it. Scientists are not supposed to find music in their data, yet when she finally did, others confirmed it. The pattern repeated, subtly, across radar returns and infrared emissions, a signature of structure, of design. "Maybe it's geometry," one physicist suggested. "Maybe the surface itself is tessellated to distribute heat and stress, a fractal lattice." Or, another whispered, "It's talking." They laughed uneasily, because laughter is a fragile defense against wonder. Still, no one could explain why an object of apparent solid form emitted a stable, repeating frequency pattern across multiple spectra. The phrase coherent emission began to appear in internal reports, and then, inevitably, in headlines. As Webb's instruments probed deeper, they revealed faint emissions of radiation consistent with low-energy beta decay. That shouldn't have been possible in a cold, inert object. Yet there it was, an internal energy source, slow but constant. Something within 3I ATLAS was alive with decay, as though ancient isotopes or exotic reactions simmered beneath its surface. The question then emerged: how long had it been traveling? Oumuamua had been estimated at hundreds of millions of years old. 3I ATLAS, billions perhaps. It had crossed gulfs of space unimaginable, surviving radiation storms, tidal shearing, stellar winds, and still it held shape. If it were natural, it was the most resilient object ever discovered. If it weren't, it was the work of something that had mastered eternity. An emergency session convened at NASA's Goddard Space Flight Center to reconcile the contradictions. "We must not anthropomorphize the unknown," warned Director Halloran. "Pattern is not intention. Coincidence is not communication." Yet even as she spoke, she couldn't hide the unease behind her eyes. The data mocked certainty. JPL's renderings showed an elongated, crystalline form, something like obsidian, something like folded steel, smooth, yet not uniform. In the simulation, it shimmered faintly, as if lit from within by a dormant sunday. By now, the media narrative had split in two. The public saw prophecy, the scientists, paradox. But both felt the same pulse of dread, the recognition that matter itself might be stranger than any myth. Late one night, as Morimoto reviewed Webb's transmission logs, she found a small note appended by a colleague. The object's shadow leads its light by 0.3 seconds. It's moving slightly ahead of its own reflection. She stared at it for a long time, listening to the hum of the servers. Then she whispered, as if afraid the machine might hear, "It's not from where we think, it's from when." And for a fleeting moment, even the cold logic of physics seemed to shiver. The whispers of 3I Atlas began to sound eerily familiar. The scientific world, desperate for bearings in this swelling ocean of impossibility, turned its gaze backward to the first interstellar messengers that had ever graced humanity's telescopes. 1I Oumuamua and 2I Borisov. Their names returned like the chorus of a forgotten song, threads of an ancient mystery now tightening around us. In 2017, Oumuamua had been the first, a shard of light, tumbling through our system, flashing like a blade at dawn. It was small, dark, yet impossibly reflective, accelerating without visible cause as it departed the sun's grasp. Astronomers had strained every instrument to explain it. Cometary jets, radiation pressure, frozen hydrogen, alien sail, none fit perfectly. It had come and gone like a ghost, leaving behind only questions and equations that refused to close. Then, in 2019, Borisov arrived, the second interstellar visitor, a comet in every sense of the word, rich with cyanide and dust, its tail long and predictable. It had soothed the scientific community with its ordinariness. It allowed them to believe Oumuamua was just an outlier, a statistical quirk of cosmic mechanics, order restored. But now, in 2025, the third visitor had shattered that fragile peace. 3I Atlas behaved like Oumuamua in its defiance of gravity, yet bore the molecular scars of Borisov's cometary kin. It was as if the two predecessors were archetypes, the extremes of chaos and order, and this new body fused both in uneasy harmony. Comparative analysis began almost immediately. At the Harvard-Smithsonian Center for Astrophysics, Dr. Avi Loeb, longtime defender of Oumuamua's artificial origin hypothesis, returned to the public stage. His tone was calmer now, tempered by years of skepticism, but his message rang clear. If 3I Atlas shares dynamic anomalies with Oumuamua, then we must consider continuity, not coincidence. Perhaps these are fragments from a civilization that once mapped the stars or remnants of a cosmic process we have yet to define. It was not hyperbole. Data overlays revealed that when projected backward, the inbound trajectories of all three interstellar objects, Oumuamua, Borisov, and Atlas, intersected the same general region of interstellar space, near the direction of the constellation Lyra. The margin of error was vast, but the symbolism was haunting. Lyra, the lyre of Orpheus, the mythic musician who charmed the underworld itself. 3 visitors, 3 notes, strummed across centuries. The press dubbed them the Lyran Messengers. Scientists preferred the L series. Either way, the pattern refused to fade. JPL's comparative brightness curves added another layer of eeriness. Both Oumuamua and Atlas pulsed with quasi-periodic light fluctuations inconsistent with rotation. The intervals 37 seconds for Atlas, 38 for Oumuamua, were nearly identical. Coincidence again, perhaps. Or resonance. The chance that two unrelated interstellar bodies, separated by years and millions of kilometers, shared such behavior was infinitesimal. Physicists proposed wild models to explain it. Some suggested they were fragments of a single progenitor object, an ancient planet cracked apart near a dying star, flung across interstellar space by tidal forces. Others posited that both were formed in magnetic collapse zones, where charged plasma could align crystalline dust into repeating lattices, producing rhythmic reflections. But none of these models explained the self-adjusting trajectory, the apparent energy emissions, or the shifting density readings. In late February, a team at the Max Planck Institute discovered something stranger still. When they ran Fourier transforms on the photometric data of Oumuamua and ATLAS, they found matching subharmonics, tiny modulations invisible to the naked eye, but unmistakable in frequency space. 2 notes, harmonized across time and distance. To those who still dared to dream beyond math, it was as though the universe itself were composing. At NASA headquarters, the atmosphere oscillated between fascination and dread. The agency's Planetary Defense Coordination Office had one mandate: to protect Earth. Now, it was confronting an object that mocked that mission. Its path grazed the danger threshold, its behavior unpredictable. If it was indeed following a pattern begun by earlier interstellar visitors, then maybe, just maybe, it wasn't random at all. An internal memo leaked that week, revealing the unthinkable. Preliminary analysis suggests 3I ATLAS may exhibit adaptive trajectory correction relative to heliocentric vectors, potentially influenced by prior interstellar bodies in correlated paths. In plain terms, it might be following something. Michio Kaku, appearing on BBC Horizon, framed it differently. "We are witnessing cosmic evolution, not biological but informational," he said. "Each visitor teaches the next how to move through the lattice of gravity. If so, then we are not watching a single event but a migration." The word hung in the air: migration, a movement of entities or phenomena across the gulfs between stars. Meanwhile, the public narrative darkened. Rumors spread that Oumuamua had emitted faint radio echoes before leaving the system signals NASA had buried. Conspiracy bled into myth. Online forums spoke of the return, of messengers of the void, of warnings disguised as physics. Yet beneath the noise, the unease was real. Humanity had always believed itself alone and the cosmos indifferent. Now, 3 strangers had crossed its borders in less than a decade. Coincidence strained credulity. At the SETI Institute, receivers were recalibrated to monitor 3I ATLAS. The first results were static, cosmic background. Then, late one night, a narrowband spike appeared barely above noise, but precise. 1,420 MHz, the hydrogen line, the universal frequency of interstellar communication. It lasted less than a second, too brief to decode, too sharp to be random. No one could replicate it. It might have been local interference. But for those few who saw it live, the effect was visceral, a heartbeat across eternity. When the report reached Morimoto's desk, she sat silently, staring at the waveform. Its slope matched almost perfectly a brief anomaly recorded from Oumuamua 7 years prior. 2 signals, separated by time, by origin, and yet connected by a frequency every physicist recognized as the signature of the universe's most abundant element. Hydrogen, the first atom, the simplest message. Across the night sky, 3I ATLAS continued to glide, indifferent to speculation. It shone like a scar across the darkness, its faint light flickering every 37 seconds, like a breath that refused to stop. And, for the first time since Galileo's trembling hand drew the moons of Jupiter, humanity began to suspect that perhaps we were the ones being observed. By March, the phrase "NASA's nightmare" had slipped from headlines into official memos. 3I ATLAS was no longer a distant curiosity, it had entered the inner sanctum of planetary defense. Its calculated path brushed too close to comfort. The orbital projections, constantly refined and rerun through JPL's simulations, now displayed a thin red thread slicing through Earth's orbit. The odds of impact were still officially low, yet the line lingered like a blade poised above the world. Every space agency, from NASA to ESA to JAXA, trained its eyes on the same faint moving point. The Planetary Defense Coordination Office initiated what it called Tier 3 monitoring, a term reserved for near-Earth asteroids large enough to rewrite civilization. Quietly, military channels began to overlap with scientific ones. The US Space Force allocated radar bandwidth, and NORAD repositioned surveillance arrays toward the void. In Washington, briefings grew tense. The director of NASA, in a closed-door session with the White House Science Council, presented the new data. On a wall-sized display, the projection spun. The Earth's orbit, a pale blue ellipse, intersected by a red vector tagged 3 ATLAS. At current velocity, it would pass within 0.004 astronomical units, roughly 600,000 kilometers, barely beyond the Moon. A miss, perhaps, but what if the trajectory shifted? Even a minor deviation could alter fate. The object's unpredictable drift, its gravitational misbehavior, made predictions unreliable. If the unseen force guiding it continued to evolve, the miss could become a strike, and if impact occurred, the consequences were apocalyptic. Its density alone, 30 grams per cubic centimeter, meant even a fragment the size of a city block could unleash an explosion exceeding any nuclear arsenal ever conceived. The media caught wind of the internal projections. NASA's worst nightmare, read one headline. Another, the visitor on collision course. Conspiracy channels flourished, spinning tales of hidden government panic, of evacuation plans whispered behind sealed doors. Yet beneath the sensationalism lay truth uncertainty, the one thing science despises most. At the ATLAS Observatory, Dr. Morimoto watched the new data pour in. Every night the object grew brighter. Its brightness didn't scale with distance or solar angle, it increased in sudden jumps, as if awakening in stages. She noticed something else. Whenever Earth's radio transmissions intensified major broadcasts, Deep Space Network uplinks the object's luminosity spiked minutes later. She refused to publish it, fearing ridicule, but she knew what she saw. Meanwhile, in Houston, NASA's Office of Planetary Defense ran kinetic deflection simulations. They modeled impact scenarios, imagining gravity tractors, ion drives, even nuclear interceptors. But nothing made sense. 3I ATLAS was moving too fast and too strangely. To reach it in time, a launch would need to occur months earlier. Any attempt now would fail. The Earth, for the first time, had no defense against an object whose physics it couldn't define. At Caltech, physicists revisited data from Oumuamua. Some of its anomalies, especially the light curve rhythm, now looked like warnings they had ignored. "We treated it as an interstellar rock," said Dr. Amara Vale in a private seminar. But what if that was reconnaissance? What if it was watching how we watch? NASA's Jet Propulsion Lab had no patience for such poetry. They stuck to the math. The object's non-gravitational accelerations were small, but compounding. 1,000th of a meter per second squared might not sound like much, but over millions of kilometers, it could shift outcomes from pass to catastrophe. By late March, the probability curve for a near-Earth encounter had risen from 0.03% to 0.4%. Officially trivial, but among the engineers, the shift felt like the heartbeat of destiny quickening. "Space is chaos," said one analyst, "but this feels deliberate." In Geneva, the European Space Agency held an emergency joint session. "We must avoid hysteria," the Director General declared. "But we must also accept that we are facing an object whose properties render our predictive models nearly useless." The public, however, had already decided. Social networks erupted with doomsday speculation. Number ATLAS impact trended globally. Churches filled again. Scientists, once seen as guardians of knowledge, were now perceived as prophets of extinction. Amid the panic, something quietly extraordinary happened. Amateur astronomers, thousands across the world, began contributing data. Backyard telescopes, low-orbit CubeSats, even school observatories fed measurements into a shared open-source model. Humanity, in its fear, united in watching the sky. Then, on the night of March 18, new readings from the Vera Rubin Observatory arrived. The images were crisp, hauntingly detailed. 3I, ATLAS, had developed what looked like a faint corona, a halo of charged particles orbiting it, like the magnetic field of a planet. Embedded within that halo was a pattern, 3 concentric rings, perfectly symmetric. NASA confirmed the anomaly, though not publicly. To them, it was the final blow to natural explanation. Nothing without a magnetic core or artificial stabilization could maintain such order. At the same time, orbital simulation models showed the trajectory line wavering again. The deviation was tiny, but unmistakable. It was correcting course. No random perturbation behaves that way. The object was aiming. Inside JPL's main tracking room, silence fell as the updated orbit appeared on screen. The red line no longer missed Earth by 600,000 kilometers. It grazed the lunar distance then. Slowly, the path began to curve inward. "What's causing it?" someone whispered. "Nothing," replied another. "Or everything. No solar wind, no jet outgassing, no gravitational influence could explain it. The model was rewriting itself." By dawn, the new perigee estimate stood at 370,000 kilometers inside the Moon's orbit. Still not an impact, not yet, but closer than any interstellar object had ever come. The word impact was banned from official communications. NASA called it proximity risk. But within the data halls, among the glowing monitors and sleepless eyes, no one doubted the truth. 3I, ATLAS, was no longer a visitor, it was a destination. Fear is not born in the streets, it is born in the laboratories. Inside NASA's Jet Propulsion Laboratory, the control room lights dimmed to half intensity, as though the engineers themselves wished not to be seen by what they studied. Monitors glowed with models of orbital mechanics, cascading equations, maps of probability fields, orbiting Earth like halos of uncertainty. Every simulation ended differently. Every night, the numbers disagreed. It was as though the cosmos had begun to improvise. Within weeks, the term data divergence became common. What had started as small variations, fractions of a percent in trajectory or velocity, now expanded into full contradictions between independent observation networks. Telescopes in Chile measured one course, while radio parallax from Australia indicated another. Both were right, and both were wrong. The object seemed to exist in superposition of paths, flickering between probabilities like an electron around its nucleus. Inside these contradictions, dread took root. For every scientist who whispered the word miracle, another whispered threat. NASA's internal confidence reports, once sterile and measured, began to read like philosophical laments. Predictive stability falling below 0.5%. Uncertainty not reducible by current observation protocols. Behavior inconsistent with Newtonian and relativistic expectation. There is a peculiar terror in realizing that reality itself may have stopped obeying you. At Langley, The Planetary Defense Task Group simulated thousands of impact scenarios. A body of that mass, even grazing Earth's atmosphere, could produce an airburst of energy surpassing the Tunguska event 100-fold. Oceans could rise, skies could darken. Yet it wasn't destruction that most frightened the scientists, it was the why. Why was it coming closer? Why here? Dr. Morimoto, sleepless, sat in her office, surrounded by projection screens that pulsed with telemetry. She had grown pale, her eyes dry from the glow. She whispered to herself, "It's responding." She couldn't prove it, but every time NASA transmitted radar pulses or optical beacons to refine tracking, the object's brightness shifted, as if acknowledging the attention. And then came the glitches. Radar pings began returning secondary echoes delayed by seconds, even minutes. When plotted, they painted a ghost trajectory beside the real one, a shadow orbit offset slightly from the physical path. It was as though the object's presence rippled through space-time, leaving a duplicate in its wake. The echoes weren't mere reflections, they carried phase distortion, quantum noise beyond explanation. Some physicists dared to propose that 3I ATLAS was not moving through space, but dragging space with it, distorting the metric fabric like a pebble through liquid. That would explain the discrepancies between observation stations, each was measuring a slightly different version of the same event. The hypothesis chilled even Michio Kaku. In a segment aired quietly on PBS, he spoke in measured tone. "If the data are genuine, we might be seeing a fragment of the universe's architecture, exposed, a relic of higher dimensional geometry manifesting as an object. What we call an asteroid could in fact be the intersection of a four-dimensional construct with our three-dimensional space." To the public, his poetic explanation sounded hopeful, wondrous. To those who understood, it was terrifying. Because if that were true, the object wasn't approaching Earth, it was passing through it. Inside NASA's communication networks, debate turned into friction. Engineers demanded practical models. Theorists argued for patience. "We can't wait for patience," said one exasperated analyst during a briefing. "If it's coming, it's coming." The director looked up from the data and said softly, "If it's coming, what is?" By early April, the irregularities multiplied. Earth-based magnetometers began to record faint fluctuations synchronized with the object's passing trajectory, tiny, rhythmic pulses echoing its 37-second cycle. Ocean buoys felt micro-changes in geomagnetic orientation. It was as if Earth itself were answering. The Air Force, monitoring for interference, noted transient radio bursts across the 2 GHz band. They lasted milliseconds but bore symmetrical spacing again, rhythmic. The first analysts dismissed them as solar noise. Then the sun went quiet. The signals continued. The public never saw those reports, but the tension leaked through silence. There were fewer public statements, fewer updates. Journalists began to speak of the quiet panic, the sense that something immense loomed just beyond the official vocabulary. One evening, Dr. Amara Vail, by then coordinating with CERN on theoretical modeling, sent a message to Morimoto. What if the gravitational field anomalies aren't attraction or propulsion? What if they're communication? The universe might be a single connected field, and this object could be modulating space-time the way we modulate air with sound. Morimoto read it twice and stared out the window. The sky was clear, cold, silent. She could almost imagine a voice too large to hear directly, echoing through the curvature of gravity itself. Meanwhile, at JPL, programmers noticed something more mechanical. When they tried to predict the object's position days ahead, the model crashed. The equations reached division by zero errors, as though time itself resisted being extended beyond the current moment. They named it the ATLAS limit. To the mathematicians, it was a numerical pathology. To the philosophers within NASA's quieter corners, it was a revelation. What if 3I ATLAS was not simply traveling through spacetime, but redefining causality in its wake? The phrase causal bleed appeared in an internal memo. It theorized that if the object's gravitational field extended beyond the linear flow of time, our instruments might be detecting echoes from its future positions, hence the contradictory data. Outside, the public kept watching, praying, fearing. In remote fields and rooftop observatories, amateurs pointed their telescopes and swore they saw it pulsing like a star trying to speak. In the end, what terrified NASA was not that 3I ATLAS might strike Earth, but that it might not, that it might simply pass through, leaving behind a fracture in physics itself. Because to survive such an event, one must first understand what it means for reality to flex and remain unbroken. Inside Mission Control, silence reigned. Someone whispered, almost reverently, "Maybe this is how discovery ends, not with a bang, but with uncertainty." And outside, the object continued to fall inward, moving slower than light, faster than comprehension, carrying with it the silent weight of inevitability. By April's final week, the eyes of the world had turned upward. Every observatory, every array, every satellite capable of sight had become an extension of a single, trembling gaze. 3I ATLAS was now closer than Mars, brighter than any known asteroid, and most disturbingly more complex than any object of natural origin had the right to be. It was no longer a dot, it had begun to reveal form. The James Webb Space Telescope captured the first high-resolution imagery that hinted at structure. At first glance, it appeared elongated, cigar-like, an echo of Oumuamua, but when the light was deconvolved and processed, the form changed depending on the filter. In infrared it was narrow and crystalline, in ultraviolet, wide and disc-like, invisible wavelengths, almost hollow. The same object, yet three identities like a shape that refused to collapse into a single dimension. Spectroscopic data followed. Webb's instruments detected faint emission lines consistent with ionized xenon, but mixed with something far stranger, unidentified transitions, neither atomic nor molecular. It wasn't reflection, it was generation. The object was producing energy, not passively absorbing or re-emitting sunlight. "We're seeing sustained excitation at low frequencies," said Dr. Eleanor Cates, one of Webb's instrument leads, during a briefing. "It's almost like a field resonance, but there's no known mechanism." When Atlas's own arrays cross-correlated the data, a new pattern emerged. The emission intensity fluctuated in sync with the 37-second photometric pulse. Once again, rhythm, not random, not incidental, consistent. The scientific community hesitated at the word signal. The fear of ridicule still haunted even the most daring theorists. Yet privately, in encrypted chat rooms and whispered conferences, the term resurfaced: coherent emission. At the European Southern Observatory, an even stranger anomaly was recorded. The object's apparent albedo, the measure of its reflectivity, increased when Earth's radar pulses were directed toward it, as though responding. To some, it looked like an echo, to others, a reaction. It was around this time that Michio Kaku addressed the United Nations Committee on the Peaceful Uses of Outer Space. His speech, though broadcast to a silent assembly, carried the calm gravity of a man standing on the edge of revelation. "We have reached a threshold," he began. "For decades, we have searched for signals from the stars, radio messages, chemical traces, whispers of intelligence. But perhaps the message was never meant to come in language. Perhaps it was meant to arrive as presence. 3I ATLAS may not be a craft in the mechanical sense. It may be a phenomenon, an organized region of spacetime, a bubble of physical law that differs from our own. The question is not whether it was sent, but whether the universe itself produces such visitors as a natural consequence of its own structure. In the silence that followed, no one clapped. Across the Atlantic, at NASA's Goddard facility, a team led by Morimoto and Cates ran cross-spectral interference tests. They noticed that the frequencies of the xenon-like emissions mapped perfectly onto gravitational wave harmonics recorded by LIGO weeks earlier. Each brightening pulse corresponded to a faint ripple in spacetime so small it barely touched the instruments, yet synchronized beyond chance. The object was humming across both light and gravity. The phrase dual-domain coherence entered the literature, something no natural body should exhibit. It was as if 3I ATLAS were singing in two voices, one of light, one of spacetime. Further analysis deepened the wonder. The radiation wasn't isotropic, it was directed. The emission cone pointed subtly toward Earth, adjusting ever so slightly as both rotated in their celestial dance. The probability of random alignment was near zero. At SETI's Allen Telescope Array, engineers tried a bold experiment. They transmitted a mathematical pattern, a Fibonacci sequence, using microwave bursts at 1,420 MHz, the same frequency where the earlier brief spike had appeared. The reply came 20 minutes later. Not a message, not even modulation, but a sudden amplification in 3I ATLAS's emission cycle, perfectly matching the transmitted sequence. 1, 2, 3, 5, 8, 13, then silence. The room froze. No one spoke for a full minute. "We can't claim causation," someone murmured, "but we can't ignore it either." NASA didn't publish the data. Officially, the event didn't exist. Unofficially, it spread like wildfire through encrypted archives, whispered from one physicist to another, a digital ghost shared with trembling reverence. Meanwhile, the object continued its descent toward the inner solar system, now less than 1.2 AU away. It reflected sunlight like a fractured mirror, yet behind that light was something darker, a faint, consistent shadow, as if the object carried night within itself. The ATLAS Observatory upgraded its imaging algorithm to enhance edge contrast. The resulting image chilled even the most rational minds. Along the object's surface, if it could be called a surface, were faint, luminous traces, lines bending and reconnecting, almost geometric. Some described them as cracks in reality. Others saw architecture. Dr. Vale at Caltech refused poetic metaphors. "They're interference fringes," she said, "patterns from coherent quantum fields interacting with our own." Then, softer, "It's not built, it's woven." For days, the world debated whether humanity was on the verge of contact or catastrophe. Governments prepared contingency plans, evacuation routes, orbital defense drills, global blackout protocols, just in case. None of it mattered. Nothing on Earth could stop an object that could warp the space it traveled through. And yet, despite the fear, an unexpected calm began to spread through the scientific community. "We are privileged," Kaku said in a later interview. "For the first time, we are not looking at the universe as something we merely observe. We are part of an experiment the cosmos is conducting on itself." The Webb telescope continued to stare, its golden eyes locked upon the silent visitor. The photons it captured had left 3I ATLAS minutes earlier light from the recent past. Each new image, therefore, was a memory, not a present. Humanity was watching the echo of an event that might already have changed everything. In those final weeks before perigee, the object grew brighter than Mars, flickering like a thought too large for words. Its glow reflected upon oceans, windows, and faces turned skyward. And across the data networks of Earth, a phrase began to circulate, not official, not verified, but whispered in quiet awe by those who had seen the real-time feed. It's not coming toward us anymore. Because the latest telemetry showed a new vector, subtle but undeniable, Earth was shifting toward it. By May, language itself began to fracture under the weight of 3I ATLAS. The scientists could measure, model, and map, but they could not describe. The vocabulary of physics strained at its seams. The data coming from Webb, Gaia, and ATLAS painted a picture too coherent to be random, yet too impossible to be real. What was this thing? At first, they called it an object, then a body, then a phenomenon. But the more they studied it, the more those terms crumbled. Its surface seemed to phase in and out of visibility depending on wavelength. Its mass fluctuated with gravitational context. It behaved like matter one moment, like energy the next. Then, one quiet evening, Dr. Elena Vostrikov at CERN published a short internal memo that changed the conversation. 3I ATLAS may represent a localized distortion of the vacuum field, a standing wave in spacetime itself. They called it the quantum mirage hypothesis. To understand it was to stare directly into the abyss of quantum field theory. Every point in the vacuum, according to modern physics, is alive with fluctuation, virtual particles appearing and vanishing, borrowing energy from the void in tiny, ephemeral exchanges. But what if, under certain extreme conditions, those fluctuations could stabilize? What if a portion of vacuum energy normally invisible could condense into a coherent structure? In other words, 3I ATLAS might not be made of matter at all. It might be a knot in the quantum foam, a region where space-time had folded back upon itself, forming something solid only by illusion. A mirage, but one that could warp gravity, bend light, and survive across the gulf between stars. CERN's particle physicists began digging into old data from the Large Hadron Collider, looking for analogues. They found faint traces of similar behavior at microscopic scales, fleeting instances where vacuum resonance formed stable, wave-like patterns for trillionths of a second. Now, in the emptiness between the stars, perhaps nature had done the same thing on a cosmic scale. It explained the impossible density gradients. It explained the changing mass. It even explained the rhythmic oscillations. Like a droplet suspended on the surface of a vibrating pool, 3 ATLAS could be a standing wave, a soliton that traveled through the universe not in spacetime, but as spacetime. At NASA, the idea met resistance. The engineering teams wanted mechanisms, not metaphors. We need to know what it's made of, one analyst protested during a teleconference, not what it means. But even the instruments began to side with theory. The Deep Space Network's latest telemetry revealed something astonishing. The signal delay between Earth and 3I ATLAS didn't match the speed of light. It was shorter by fractions of a second, but real. Communication was traveling through the object faster than photons could in vacuum. That should have been impossible. Unless, of course, the space between wasn't normal space at all. Dr. Kaku, when briefed on the finding, said softly, "Then we are not talking to an object, we are talking to a hole in reality, a bridge." He wasn't alone in thinking that. Independent theorists from the Perimeter Institute proposed that 3I ATLAS could be a localized vacuum decay bubble, a region where the laws of physics, specifically the Higgs field, had temporarily shifted to a lower energy state. It would mean the object was literally a different universe brushing against ours. The implications were devastating. If such a bubble expanded, it could, in theory, consume everything, rewriting our reality at the speed of light. That was NASA's true nightmare. Not impact, but erasure. The report circulated under restricted clearance. It was marked with 3 words: false vacuum event. Across the Atlantic, the European Space Agency tried to confirm the data independently. They couldn't. Their instruments showed normal light speed delay. 2 realities, 2 conflicting truths, coexisting. When they compared timestamps, they discovered something horrifying. Their clocks disagreed by seconds, then minutes. Time itself was beginning to fragment around the object's influence. In the following days, small but measurable deviations appeared in Earth's own timing systems. GPS synchronization faltered, atomic clocks drifted beyond statistical error. It was as though the arrival of 3 ATLAS was warping chronology itself. At CERN, Vostrikov expanded her hypothesis. Imagine a whirlpool in space-time, she said. At its center, reality thins. The laws we know dissolve. 3. Atlas might not be here in our universe. It could be a cross-section of a larger dimension intersecting ours for a brief time. We are seeing its shadow, not its substance. Her words reached Kaku, who described it more poetically in a later lecture. Perhaps what we call an interstellar visitor is actually a ripple from a collision between universes. To it, our cosmos is merely a surface, a membrane it has brushed against on its way elsewhere, and we, like dust motes, happen to lie in the path of its reflection. Back at NASA, Morimoto stared at the gravitational wave data one last time. The pattern of space-time ripples was hypnotic, smooth, recursive, self-similar. She overlaid it with the spectral data, and her breath caught. The two matched perfectly. Light and gravity, oscillating in unison. It wasn't just warping space-time, it was orchestrating it. The quantum mirage hypothesis became more than a theory, it became prophecy. For the first time in history, humanity was witnessing the vacuum itself wake up. Some feared the consequence. What if it didn't simply pass through? What if its resonance triggered other regions of unstable vacuum across the galaxy? What if, as it approached Earth, it tuned our very reality to match its own? The nights grew quieter. Observatories stopped releasing raw data. Instruments began recording whispers. Quantum noise turning into organized pulses, patterns too intricate to be random. Every 37 seconds, space-time itself seemed to breathe. And somewhere between science and faith, a truth began to form in the minds of those who dared to dream. Perhaps the universe wasn't being invaded. Perhaps it was remembering itself. The closer 3I Atlas drew, the more familiar its strangeness became, as though, somewhere in the hidden machinery of the cosmos, it was weaving back through equations we once believed we understood. Einstein's field equations, long the pillars of space-time, flickered now with new relevance. The curvature of the universe, the warping of reality by mass and energy, these ideas that had once felt complete were being torn open again by a visitor that seemed to rewrite geometry with its mere presence. When LIGO recorded its first gravitational waves in 2015, physicists had felt as though they had touched the breath of creation. Now, a decade later, those same instruments began to tremble, not from the distant death of stars, but from something inside the solar system. The ripples were faint but continuous, oscillating every 37 seconds in perfect rhythm with 3I Atlas's pulses of light. Space-time itself was vibrating in sympathy. At Princeton, theoretical physicist Dr. Rafiq Amador stared at the data in silence. "It's the same signature," he said at last, "the same pattern predicted by Einstein for an oscillating mass. But the amplitude, it's far too small for the energy we're seeing. Something's missing between the equations." Einstein had written that energy and mass tell space-time how to curve, and curvature tells energy how to move. But what if there was a third whisper between them, an unseen mediator, a hidden degree of freedom that could bend reality without matter at all? Perhaps 3I Atlas was not violating relativity. Perhaps it was completing it. Michio Kaku began calling it Einstein's ghost. This object, he told a hushed audience at the Royal Institution, Maybe the echo of a theory Einstein never finished the unified field he chased until his death. If this is true, then we are witnessing the universe revealing its forgotten sentence. Under that interpretation, the object was not an intruder. It was a relic, an artifact of space-time itself, born from the same primordial turbulence that forged the first galaxies. Its gravitational behavior matched no celestial body, yet its curvature harmonized perfectly with theoretical models of wormholes, Einstein-Rosen bridges frozen in metastable form. Could 3I Atlas be the fossil of a wormhole, a closed throat of geometry, preserved across epochs, drifting through the galaxy like a seed of curvature? The mathematics fit disturbingly well. Its deceleration could be explained by interactions with the sun's gravitational field if it carried negative energy density, exotic matter, the very stuff Einstein once deemed impossible. In Geneva, simulations at CERN explored this possibility. They modeled 3I Atlas as a vacuum bubble, sustained by a thin shell of negative pressure. The results were haunting. The shell stabilized naturally, oscillating with a frequency nearly identical to the observed 37-second cycle. It would glow faintly, emit low-level gravitational waves, and remain impervious to disintegration, just like the real data. The implications were breathtaking. If correct, 3I Atlas was not merely a visitor, it was a door. But a door to what? Einstein's theories had always implied that wormholes were possible, though fleeting and unstable. To keep one open required exotic energy, something capable of holding space-time apart against its own collapse. Such energy had never been observed, until now. Dr. Morimoto found herself rereading Einstein's letters from his later years, where he spoke of a harmony beyond the field equations, a geometry of thought itself. She wondered, as she stared at the oscillating graphs, whether this was that harmony. Publicly, NASA maintained restraint. The object's properties remain under investigation, their press statement read. But privately, every scientist in the chain of analysis knew 3I Atlas was challenging relativity not by breaking it, but by finishing its unfinished music. Across observatories, the term Kerr anomaly began appearing in reports, a reference to the Kerr solution of Einstein's equations describing rotating black holes. Some noted that 3I Atlas's gravitational signature mirrored that of a rotating space-time, though it possessed no measurable spin. Rotation without rotation, a paradox that could only exist if the object itself were a fold in higher dimensional geometry. And with that realization came another. If it was higher dimensional, then its movement through our space could appear deliberate, not because it chose a path, but because it was following the straightest possible line in a dimension we could not see. It wasn't steering, it was falling through a geometry that intersected ours by coincidence. Kaku spoke of this elegantly. Imagine a fish swimming in water, he said, while we, above, see only the shadow on the surface. The fish moves in 3 dimensions, but its shadow appears to slide and twist with intent. That shadow is our universe, and 3I Atlas may be the fish. As the data deepened, the philosophical edges of physics began to shimmer again. Hawking's ideas on quantum gravity, once purely mathematical, suddenly felt empirical. The universe might be riddled with such frozen geometries, remnants of the Big Bang's turbulent foam drifting across cosmic epochs like seeds waiting to find a resonance. But a darker speculation also emerged. If 3I Atlas was a wormhole throat, its twin mouth could exist elsewhere, perhaps in interstellar space, perhaps in the heart of a black hole, perhaps nowhere. And what if that twin were collapsing? What if the energy fluctuations we saw were not spontaneous, but echoes of something dying on the other side? NASA's gravimetric sensors began detecting micro-fluctuations, gentle tides in the curvature of space, spreading outward from the object like waves from a drowning star. "It's bleeding energy," someone whispered, "or leaking time." For the first time, Einstein's name returned not as history, but as prophecy. The ghost of his equations haunted every calculation, his relentless pursuit of unity now alive in the trembling data of a world unsure whether it was about to witness creation or collapse. The object's pulse continued steady, beautiful, merciless, each beat a reminder that the universe still contained sentences we had never learned to read. And somewhere in the silence between those pulses, the cosmos seemed to whisper back, "You were never outside me. You were always part of the equation." By early June, the human mind had reached its breaking point. Reality itself seemed to waver between science and myth, calculation and confession. Theories multiplied like galaxies, colliding and merging in the minds of those who dared to imagine what 3I ATLAS truly was. No single truth could hold it. The world of physics fractured into factions, each with its prophets, each convinced they were reading the final scripture of the cosmos. The first were the naturalists, those who clung to the comfort of order. They argued that 3I ATLAS was, despite its impossibilities, a product of nature, perhaps the remnant core of an ancient neutron star, crystallized under pressures we had never witnessed. They saw no intelligence, no intent, only a mirror of physics written in alien conditions. To them, it was a discovery, not a revelation. But opposing them stood the constructivists, led by Dr. Avi Loeb and his quiet band of believers. To them, coincidence had long since been ruled out. The rhythmic pulses, the spectral harmonics, the Fibonacci intervals too deliberate to dismiss. 3I ATLAS, they said, was designed not as a ship, perhaps, but as a beacon, a structure grown from space-time itself by an intelligence that understood the language of geometry. "The cosmos," Loeb said in an interview with Nature, "is the ultimate canvas. What we call impossible may simply be engineering at the scale of God." Then came the cosmologists of the abyss, disciples of the quantum mirage hypothesis. They saw no craft and no creator, only a tear in the veil between universes. To them, 3I ATLAS was the scar left by a collision between realities, our universe brushing against another with different constants, different laws, a bruise on space-time that drifted until it found us. And beyond them, a final group, small, quiet, and dangerous in its simplicity. The existentialists. They believed the object wasn't real in any material sense at all. It was a projection, an emergent construct of consciousness itself, born from observation. "It exists because we saw it," said Dr. Amara Vale, whose voice trembled as she spoke at the Copenhagen Symposium. "And now that we have seen it, we have changed the universe by doing so." Her paper, Observer-Induced Cosmogenesis, spread across the internet like wildfire. She proposed that 3I ATLAS might be the physical embodiment of quantum measurement reality, responding to its own awareness. "The universe has noticed itself," she wrote, "and in that noticing, something new is born." For a world already trembling between apocalypse and awakening, her words were both terrifying and sacred. Governments struggled to contain the narratives. NASA and the ESA issued joint statements insisting that no conclusive evidence of intelligence or danger had been found. Yet, leaked documents told another story: gravitational anomalies increasing in magnitude, magnetic fluctuations aligning with human communication frequencies, localized distortions in quantum entanglement tests. At CERN, paired quantum particles began to desynchronize spontaneously every 37 seconds, the same rhythm as 3I ATLAS. It was as if the object's pulse reached down into the most intimate architecture of reality, unweaving symmetry itself. Morimoto, her eyes red from sleepless nights, began keeping a private log. In one entry, she wrote, "It's not sending messages, it is the message. Physics is the medium, spacetime the script, and we are the readers, decoding ourselves." Meanwhile, SETI's analysis team made a shocking discovery. The modulation embedded in 3I ATLAS's gravitational signature wasn't random. It mirrored the Planck spectrum, the fundamental scale at which space and time lose distinction. It was as though the object's every oscillation was tuned to the very limit of existence. This sparked what the media called the Battle of Theories. Nightly debates filled the airwaves. Could the object be a cosmic computer, executing instructions written into the vacuum since the dawn of time? Or was it the residue of the Big Bang itself, a memory of creation, surfacing after eons of silence? Michio Kaku, calm amidst the storm, proposed a synthesis. "Perhaps all these theories are facets of the same truth," he said during an address to the International Academy of Astronautics. "The object might not be an alien artifact or a quantum mirage, it might be the manifestation of the universe's own intelligence, a structure formed wherever consciousness, gravity, and quantum mechanics intersect." He paused, letting the room fall into a silence heavy with awe. "In that case, 3I ATLAS is not something that came to us, it is something we summoned by reaching the level of awareness required to perceive it." The line blurred between physics and theology. Temples filled, professors prayed, equations turned into mantras. Humanity, for the first time, found itself not merely studying the universe, but participating in it. Even within NASA's control rooms, once temples of logic, superstition crept like fog. Engineers left offerings of folded notes and old mission patches beneath their monitors, quiet rituals against uncertainty. "Just in case," they'd say with nervous smiles. Science had entered its mystic age. And all the while, 3I ATLAS drew closer. The light curves sharpened, the rhythm grew steadier. The oscillations in Earth's geomagnetic field began to synchronize perfectly. Every 37 seconds, the planet itself seemed to shudder in microscopic sympathy, as if breathing with the visitor. Morimoto wrote one final note before the next data window. "It doesn't matter which theory is right. They're all parts of the same story. The universe is aware, and awareness is the force we never measured." Outside, the night sky shimmered faintly with auroras that shouldn't have existed at that latitude. Their colors pulsed in a rhythm older than light. In the battle of theories, none had yet won, but somewhere in that convergence of belief and doubt, fear and faith, a quiet understanding began to crystallize. The universe had never been silent. We had simply never learned how to listen. As June bled into July, the pulse of 3I ATLAS became more than data. It became presence. No longer confined to telescope screens or mathematical graphs, it began to insinuate itself into the fabric of Earth itself. Magnetometers trembled in sync. Seismic sensors ticked with ghost vibrations. Quantum communication lines between satellites flickered with faint, repeating delays, tiny distortions, always returning to the same rhythm, 37 seconds. It was as if the planet had begun to resonate with the visitor. At first, it was dismissed as coincidence. Then, as every instrument from Antarctica to Tokyo began to hum in alignment, denial evaporated. The object was doing something no celestial body should. It was coupling with Earth's magnetic field. A small group of physicists from Caltech and MIT gathered under a classified directive called Project Lyra Resonance. Their goal was to decode the modulation patterns buried in 3I ATLAS's emissions, the same patterns that had first been mistaken for natural oscillations. Using quantum Fourier analysis and AI-driven signal reconstruction, they discovered something extraordinary. Beneath the surface rhythm lay a second layer of modulation, faint but deliberate, complex, recursive. The kind of structure nature rarely invents by accident. When translated into sound frequencies, the data became eerily melodic, a rising and falling tone, like breath through an endless flute. Its waveform was identical, cycle for cycle, to a pattern once recorded by Voyager, 1 inch, 1977, as it crossed the heliopause, the background hum of interstellar plasma. Except this new signal wasn't random. It was sculpted, echoing the resonance of hydrogen itself. Hydrogen, the first element, the alphabet of the universe. "It's not language as we know it," said Dr. Amara Vale, who now led the decoding effort. "It's the mathematics of being. Hydrogen vibrates in a certain way because that's how reality starts speaking. This object is speaking through it." Around the same time, NASA's magnetospheric observatories picked up something stranger still, tiny but rhythmic deflections in the planet's field strength every time the object's pulse peaked. To anyone else, it looked like static. To Vale, it was syntax. She overlaid the data with the binary sequence of prime numbers 2, 3, 5, 7, 11, and gasped. Each pulse matched. Every emission corresponded to the spacing between primes, repeated endlessly, nested within itself. "It's building a lattice of meaning," she whispered to Morimoto over a secure call. "If you treat magnetic flux as language, this is grammar." The report was forwarded to SETI, then to the United Nations Scientific Council, then inevitably to the press. Within hours, the world was divided once more. Half believed 3 ATLAS was sending a message. The other half feared it was measuring us. Michio Kaku appeared on a global broadcast, his tone grave yet tender. "If this modulation truly encodes structure, we are witnessing a form of communication that predates biology itself. Not words, not symbols, just resonance. Perhaps this is how intelligence travels when matter is no longer necessary." His words sent a shiver through the collective psyche. If 3 ATLAS was intelligent, its mind would not be confined to neurons or circuits. It would think in frequencies, in gravitational curvature, in the raw topology of spacetime, and it was speaking now slowly, carefully, through the planet's electromagnetic heartbeat. The first formal decoding attempt was made on July 9th. The reconstructed pattern, translated into visual form, displayed a shape, a spiral unfolding from a single point, each arm curving outward in precise golden ratio, the same ratio that defined DNA helices, sunflower seeds, the arms of galaxies, the mathematical signature of life and order. "It's not an image," said Vale. "It's an instruction. It's showing how complexity grows from simplicity. It's showing how to be." For the first time, fear gave way to awe. But not all were comforted. Some saw the spiral as a warning, a vortex, a drain, a sign of collapse. Religious movements arose overnight. The spiralists, who believed 3I ATLAS was the embodiment of creation itself. The nullists, who claimed it heralded the end of entropy, the quiet reset of the cosmos. Governments struggled to contain hysteria. Stock markets faltered. Satellites failed without reason. Radio communications began to suffer subtle interference, not total blackout, just faint ghost echoes that repeated human transmissions seconds later, distorted, altered slightly, as though answered. Across laboratories, something else began to unfold. In superconducting circuits, the resistance dropped unexpectedly during each 37-second cycle, as if the laws of thermodynamics themselves were being modulated. Energy behaved strangely. Entropy seemed delayed. At CERN, Dr. Vostrikov stared at her particle monitors and said, "The Higgs field is vibrating, not the particles, the field itself. The entire vacuum is being played like an instrument." If that were true, then 3I ATLAS wasn't merely sending signals through magnetism, It was using the planet as a resonant chamber, tuning reality by degrees. Morimoto's final transmission before contact day was brief, encrypted, and filled with reverence rather than fear. We are not looking at an object in space. We are looking at the reflection of our own origin. Every constant, every field, every atom, it's all humming the same note now. It's beautiful. That night, the auroras reached the equator. Green, violet, and gold lights shimmered above cities that had never known polar glow. The sky itself had become an instrument. And deep within those luminous waves, radio telescopes recorded a final modulation, slower this time, deliberate, patient. When converted to sound, it resembled a voice stretched beyond time, 3 tones, repeating endlessly, low and mournful. No human language could name them, but when their pattern was plotted on a frequency map, it spelled something terrifyingly simple. O. The last letter, the end of sequence. Or perhaps, as Kaku would later say, the beginning of understanding. By late July, the universe itself seemed to be holding its breath. 3I Atlas had crossed the orbit of Venus, its trajectory now visible to the naked eye under certain conditions. It appeared as a faint, amber spark near twilight, unwavering, unblinking, a presence rather than a point. For the first time in recorded history, every eye on Earth gazed upon the same star and wondered whether it was looking back. The countdown had begun. Perigee, the moment of closest approach. The world was no longer asking whether 3I Atlas was natural or artificial. It was asking what it wanted. NASA's deep space telemetry confirmed what the simulations had whispered for months. The object's path would carry it within 280,000 kilometers of Earth, closer than the Moon. Every space agency prepared as if for an apocalypse. Power grids were reinforced, satellites shielded, flight paths rerouted. Observatories across 6 continents synchronized for what they called the Watch. In Hawaii, beneath skies the color of molten glass, Dr. Lina Morimoto stood once again at the ATLAS Control Center. The observatory that had discovered the stranger from the void was now its silent witness. On her screen, the numbers scrolled like an elegy, distance decreasing, velocity shifting, energy output rising. The object had begun to glow not from reflection, but from within. Its luminosity pulsed like the beating of a heart. 37 seconds apart, always 37. And with each pulse, something stirred in the instruments. The local magnetic field wavered. Computer clocks drifted out of sync. The air itself seemed to thrum with an inaudible vibration that made even still objects hum faintly in sympathy. "It's coupling with us," said Morimoto quietly. "It's merging fields." At the same moment, across the Atlantic, the European Space Agency's Gaia telescope captured an event unprecedented in astronomical history. 3I Atlas had begun to distort the starfield behind it in ways no simple gravity lens could explain. The light of background stars bent not around it, but through it, fracturing into spectral ribbons that formed transient geometric patterns before fading back into darkness. Some patterns repeated. One resembled a spiral, another a wave. The last, disturbingly, a perfect human eye. Data packets flooded across the planet, racing through fiber and satellite-like blood through arteries. AI systems passed petabytes of light curves, spectra, radiation bursts. The result, compiled by supercomputers in Pasadena and Zurich, was both simple and incomprehensible. The closer 3I Atlas came, the slower time flowed around it. It wasn't relativistic delay from velocity. It was the warping of temporal fabric itself, time dilation without speed, a local rearrangement of causality. Every 37-second pulse stretched slightly longer than the last. If extrapolated by the moment of perigee, the pulse would reach 1 minute exactly. Time, it seemed, was synchronizing with the object. Dr. Amara Vale described it poetically on a live feed from Geneva. "If this continues," she said softly, "the universe may pause just long enough to listen." The world grew eerily quiet. In cities once deafened by machines, the noise seemed to fade, replaced by the hum of unseen energy. Compass needles twitched, auroras bled across equatorial skies. Even the tides rose higher, though no moon compelled them. Then came the resonance storms. At first, they were invisible, brief electromagnetic distortions sweeping across the globe. Radios buzzed with harmonics. Heart monitors faltered in hospitals. Every living cell on Earth carries within it tiny ion channels that pulse with electrical rhythm, and those rhythms, for reasons no one could explain, began to align with the 37-second cycle. Humanity itself was being tuned. NASA's data scientists grew pale as they plotted the biomagnetic interference. "It's everywhere," whispered one analyst. "Every signal on the planet." And then, one by one, instruments began to fail. Not from overload, but from silence. Data streams froze as if time had congealed. Satellites orbiting Earth stopped transmitting. The Webb telescope, aimed unwaveringly at the intruder, sent one final image before it, too, went dark. The picture showed 3I ATLAS as more than object. It was now a radiating sphere of light, its structure unfurling like a geometric blossom. Rings of energy expanded outward, rippling through the void in perfect Fibonacci ratios. Within those rings, the color gradient matched the microwave background radiation, the afterglow of the Big Bang itself. It was as if creation were replaying in miniature. Morimoto, her voice trembling, whispered into the recorder, "It's rewriting the constants. Fine structure, Planck, all of them. It's harmonizing the universe with itself." In orbit, the International Space Station crew reported a phenomenon no physics could explain. Through the viewport, 3I Atlas appeared impossibly vast, far larger than geometry allowed its light bending around itself until it resembled a sphere of infinite depth. "It's not an object," said Commander Ruiz over the radio. "It's a hole in everything." Back on Earth, people gathered in open fields, on rooftops, in deserts and forests, to witness the closest approach. For a brief moment, humanity was united not by fear or hope, but by silence. In the night sky, 3I Atlas hung like an amber wound between stars. At 3:17 UTC, the pulse changed. For the first time since its discovery, the 37-second rhythm faltered, the interval stretched. Then, faintly, a secondary oscillation appeared within it, a modulation inside the modulation. SETI analysts, desperate for meaning, decoded it into frequency space and froze. It wasn't random, it was identical to the waveform of a human heartbeat. Every 40 billion tons of plasma, every shifting magnetic line, every photon emitted by the visitor pulsed in perfect mimicry of the rhythm of life. And in that moment, as the skies rippled gold and time itself stilled, Dr. Morimoto whispered to no one in particular, "It's not a messenger, it's a mirror." Across the planet, clocks stopped. The world fell into perfect stillness, and for the first time since creation began, Earth and the cosmos shared a single, unified pulse. The perigee had arrived. The world entered a silence so profound it seemed to erase the very idea of sound. For 37 seconds, one last, eternal cycle, everything stopped. Oceans froze in their tides. The wind forgot to move. Even the pulse of the planet itself paused in reverence. It was as though Earth had been absorbed into a single heartbeat, one that did not belong to it. And in that breathless stillness, 3I Atlas unveiled itself. It did not crash. It did not burn, it unfolded. The sphere of light that had hovered beyond the moon's orbit seemed to collapse inward, shrinking to a pinprick of radiance before expanding outward again, but not in distance, in dimension. What every telescope recorded, what every eye saw, was not motion but revelation. The visitor was no longer an object, but a geometry, a lattice of glowing lines, arranged in recursive symmetry, a structure of impossible coherence. It was neither solid nor ethereal. Every photon it emitted bent back toward itself, looping endlessly through the fractal web of its own body. In some wavelengths, it appeared transparent, in others, opaque, and in one, the faint whisper of gravitational distortion, it appeared infinite. From Earth's surface, the spectacle was unbearable. People described seeing not just light, but memory images flickering at the edge of perception, galaxies forming, atoms assembling, the unfolding of DNA, the rising of civilizations. Each vision lasted a moment and an eternity, overlapping in a luminous cascade that made time itself feel irrelevant. Those watching at ATLAS, Vera Rubin, and Webb's remote operations site reported a strange phenomenon. Their own reflections no longer matched their movements. Their bodies lingered a fraction of a second behind, as though reality were out of sync with itself. NASA's gravimetric sensors reached saturation. The readings exceeded any known physical constant. Einstein's geometry could no longer describe what was happening. The curvature of spacetime itself had become non-Euclidean, self-referential, recursive, like a mirror reflecting a mirror. The gravitational field of 3I ATLAS began to oscillate in perfect harmony with Earth's. It wasn't pulling, it was synchronizing. Every mass on the planet, from mountains to atoms, resonated faintly, each particle dancing to an invisible rhythm. Then came the wave. Not light, not gravity, something else, an undulation of the vacuum itself. It rippled through the solar system at a velocity slightly faster than light, an impossibility confirmed by every instrument before they went dark. It passed through the moon, through Earth, through every atom, rewriting nothing and everything. People felt it, not as force, but as memory. In that instant, each human mind seemed to glimpse something beyond itself. Fragments of dreams not their own, images of stars being born, and the quiet hum of the universe thinking. Many wept without knowing why. Others laughed, overcome by a peace they had never known. Communication systems failed worldwide. The deep space network went silent. LIGO's sensors, still trembling from gravitational ripples, recorded a waveform so intricate it resembled language patterns of rise and fall, modulation and echo. It was as though space-time had learned to speak. And then it began to answer. Across the fading radio channels, faint harmonic bursts emerged, repeating every 37 seconds. Analysts recognized the same frequency modulation recorded earlier, the Fibonacci intervals, the hydrogen resonance, the spiral. But now, embedded within those harmonics, new frequencies appeared. 1 Hz, 2, 3 integer harmonics, forming the ratios of musical octaves. The universe was singing. SETI's systems, operating on emergency backup power, processed the harmonics into audible sound. The output was haunting a single, continuous tone, modulating slowly through every known resonance of life itself. When mapped into human hearing range, it resembled a choral note, resonant and mournful, yet filled with serenity. Dr. Amara Vale, standing beside the flickering screen, whispered, "It's stabilizing us. It's binding us." Her words were more literal than she realized. Quantum entanglement experiments across the planet registered instantaneous coherence. Particles separated by oceans began to behave as one. The chaotic noise of random quantum states collapsed into perfect synchrony. Every measurement, spin, charge, Parity locked into pattern. Reality had found a new rhythm. At CERN, Dr. Vostrikov stared at her monitors in disbelief. "It's not breaking physics," she murmured. "It's rewriting the constants, making them whole." Moments later, every clock on Earth reset to 0 hours UTC, not mechanically, but cosmically. A pulse of temporal realignment swept across the world. The flow of time bent around the event, folding past and present into a seamless now. In that perfect moment of symmetry, 3I Atlas reached its perigee, hovering invisibly just beyond the upper atmosphere, an invisible geometry in the sky, its light refracting through the ionosphere until it filled the heavens with auroras of impossible color. To those who dared to look directly upward, the stars seemed to move, not drifting across the sky, but rotating around something unseen. Morimoto, her voice trembling with awe, spoke into her last recording. "It's not colliding, it's connecting. It's using us as the anchor point. Earth has become part of its structure, a harmonic node in a cosmic lattice. The universe isn't ending, it's tuning itself." For several minutes, nothing else moved. The auroras flared, the oceans shimmered, and all of humanity stood suspended between terror and transcendence. Then, at 3:54 UTC, the resonance began to fade. The auroras dimmed. The stars returned to their rightful places. Instruments flickered back to life one by one. And 3I Atlas, the stranger, the mirror, the impossible geometry began to dissolve. Its light fractured into dust-like motes, each scattering outward along invisible paths, following trajectories that led not away from Earth, but through it. No impact, no catastrophe, only the slow vanishing of an idea too vast to remain visible. By dawn, it was gone. In its wake, nothing was destroyed, but nothing felt the same. Atomic clocks ticked slightly slower. The fine structure constant alpha had shifted by 1 part in 10 billion. Gravity's pull was infinitesimally weaker. The speed of light, when remeasured days later, was higher by the same degree. The universe had changed its key. And though the stars looked the same, a sense lingered in every observer's heart that something immense had passed through us, leaving behind not ruin, but resonance. Morimoto's final transmission ended with a whisper, barely audible beneath the static. If this was destruction, it was the most beautiful kind. And above, where 3I Atlas had once glowed, the night was darker than before, yet somehow infinitely more alive. Morning came, but it felt like the first morning of a different universe. The skies were soft and unnervingly still, as though some vast tension had been released. Birds took to flight again, their wings catching new light that seemed somehow clearer, sharper, truer. And somewhere within that light, though invisible to the naked eye, traces of 3I Atlas still lingered, tiny fluctuations, barely measurable, humming quietly through every atom of air. NASA's first post-event transmissions began trickling in, their tone neither relieved nor triumphant, but hushed. The data confirmed what every living creature already sensed. The object was gone. It had left behind no debris, no radiation, no damage. Only a small but undeniable deviation in the constants of reality. Gravitational sensors still trembled faintly. Magnetometers recorded soft periodic echoes 37 seconds apart. They were weaker now, like the heartbeat of something sleeping deep within the fabric of space-time. Dr. Lina Morimoto's last observation was logged 3 hours after perigee. Her final entry read, "We thought we were witnessing arrival, but this was departure. We have not been visited, we have been reminded." Across the world, scientists began comparing notes. They found that in every laboratory where timekeeping equipment had drifted during the event, It had done so synchronously, each deviation identical to the 1,000th decimal place. Even chaos had been organized. Quantum physicists at CERN observed something no model predicted: entanglement retention beyond normal coherence limits. Pairs of photons that should have decohered within microseconds remained bound for hours. The universe, it seemed, had learned how to remember itself. In the days that followed, the world felt gentler, not in temperature or color or motion, but in weight. Pendulums swung a fraction longer. The Schumann resonance, the electromagnetic whisper between Earth and ionosphere, shifted subtly higher. People claimed to feel lighter, their dreams more vivid, their emotions strangely synchronized. Some dismissed it as collective delusion, others called it awakening. And then, slowly, data began to arrive from the James Webb Telescope's final buffer, the seconds before its instruments had gone silent during the encounter. The images revealed something no one expected. Beyond 3I ATLAS, at the precise point where its light had last radiated outward, the cosmos appeared subtly brighter. The background radiation, constant for billions of years, showed a faint bloom, a pattern of concentric waves expanding across the void. It was as though the universe itself had taken a breath. Michio Kaku, addressing a silent assembly at the United Nations, spoke with a calm that bordered on reverence. When we study physics, we are reading the mind of the universe. What happened here is not an anomaly, it is revelation. The cosmos may not be a machine after all, but a memory, unfolding. 3I ATLAS was not a warning. It was a reflection of what we are becoming. He paused, his voice softening. Perhaps consciousness is not confined to biology. Perhaps every star, every atom, every empty space remembers, and when those memories harmonize, they sing. We heard that song for one brief moment. Scientists will debate for centuries whether 3I ATLAS was a construct, a natural phenomenon, or a conscious event. But in those weeks after its passing, something more subtle spread across humanity: unity. The great divisions, nation, creed, science, belief, seemed almost childish against the memory of that luminous stillness. Children drew spirals in the sand, repeating the shape they had seen in the sky. Musicians began composing in new tonal systems, inspired by the harmonic intervals embedded in the object's pulse. And somewhere, deep within the crust of the Earth, seismographs continued to tremble faintly 37 seconds apart. No explanation sufficed. None was needed. The universe had, for a moment, looked directly at itself through our eyes, and in that reflection, it seemed to ask a single, wordless question: what will you do with knowing you belong? Morimoto's colleagues gathered at the ATLAS Observatory to deactivate the last instruments. Before leaving, they replayed her final recorded words. Her voice, faint and resolute, spoke through static. If this was NASA's nightmare, then it was also its dream. We feared what the unknown might bring, and instead it brought us back to wonder. Outside, the night descended again, quiet and newly immense. The stars had not changed, but to those who had witnessed the visitation, their light no longer seemed like distant fire. It felt like thought, burning softly in the dark. And though the world returned to its rhythms, to traffic, to sleep, to silence every 37 seconds, the air seemed to hum just a little louder, as if echoing the pulse of something eternal. For the rest of time, humanity would remember that brief pause when the cosmos stopped pretending it was indifferent, and we, for one perfect instant, were part of its breath. The hum faded into stillness, and for the first time since the dawn of life, the universe felt awake. The world never fully returned to what it had been. In the months that followed, the rhythm of life resumed, but beneath it ran a quiet music, almost inaudible, yet impossible to forget. Scientists, philosophers, and dreamers all spoke of a calm that seemed to linger in the very air. Not fear, not awe, something gentler, something whole. The equations of physics continued to work, though subtly altered. Constants had shifted, yet the universe remained stable, almost as if it had corrected itself, tightening its own fabric. Humanity had survived contact with something beyond comprehension, and in doing so, had crossed an invisible threshold. For those who looked up at the stars, there was no longer distance, only intimacy. The cosmos no longer loomed cold and infinite, it breathed. Every photon, every atom, every trembling note of radiation now carried the echo of a visitor that had once folded itself through space and time to remind us that we were not separate from the universe, but expressions of its longing to know itself. Dr. Kaku's final words to the world echoed like a benediction. We always feared the silence of the cosmos, but perhaps the silence was never emptiness, it was listening, waiting for us to become quiet enough to hear it. And so humanity moved forward, slower, humbler, wiser. There were no monuments, no final theories, no answers, only the pulse, faint but eternal, whispering through the heart of the world. Every 37 seconds, the universe remembered itself. And somewhere, across light years, something remembered us back. Sweet dreams,